Okay, good afternoon, and thank you for coming to my talk. It's the last day of conference. Do you enjoy it so far? Who is first time at NDC London? Okay, approximately half. Very good. So my name is Vagif Abilov, and I will be talking this hour about how to survive long event history. I work as engineer at NRK. It's a Norwegian Broadcasting Corporation. You can compare it with BBC. It's like BBC, but just in Norway. I also play keyboard at the band Linebreakers, who played yesterday gig. So if you happen to be on the concert, I was there. Thank you for coming in that case. And my day job, I work with F# and C#, primarily F# last years, but our topic has nothing to do with choice of programming language or platform. It's absolutely agnostic. So whether using Java or .NET or some other platform, who is mainly using .NET in development? Oh, majority. Java, one hand, yeah. Anybody using F# by chance? No, but don't be threatened, don't be scared. This talk is platform and language agnostic. So it's also domain agnostic, more or less. We'll talk a little bit about some domain-specific things, but just to present what is our domain and actually what is a foundation of learnings, of experience, which I built for my talk. It's publishing media files. So our subdomain where we work is publishing media content. It can be TV programs, anything that NRK produces themselves or license, audio, video files, subtitles, radio programs, of course, just audio. Media supplement for news feeds, because today's news you can't manage them without multimedia, without video, audio files, and of course we publish them. And of course associated metadata, we also publish them. So you can see that this is a system that has quite strong requirements when it comes to scalability and security also. And of course it should be up and running 24/7. So it's if there are some news, breaking news, and we haven't published within a second news clip, it's a little crisis for us. And but it happens less and less of these incidents. So I don't remember last time when I had to be awakened during the night to do something. And partially that was because of our approach to how do we handle incoming data, incoming events, how we build state of our system. So our domain command and events, I guess even if you not working with multimedia domain, but this is something that everybody experiences. So you know pretty much what happens in this domain. So we publish some media content, which means that we can maybe add or remove files. Files can be retranscoded, can be some errors with the file. Of course, subtitles. In Norway, everything which are in foreign languages comes with subtitles. So it's there is no tradition of dubbing content. Of course, broadcasting rights, we must respect them. There can be multiple media resource versions. Also, some content can be geo-blocked. So while I'm here in London, I can't watch some of the videos published by NRK, by our team, because I'm in London. It's only available for Norway, and so on. So before we jump into how to the topic of survival, we have to probably define. We have to make some definitions. So definition of longevity. So when we say that we want to survive long event history, so how long event history we're talking about? And the answer is indefinitely long. So what we want to survive is that even if we rewrite our system from C# and F#, or maybe then in Rust. And if we change our data sources, if we change our message queues, which we did several times, we want our events to survive. So we can still we should still be able to play back the state of our entities from those events. And the scope of the talk also surviving what event history, because we need to talk a little bit about what do we mean by events and what happens to event history. And of course, you might guess that I will be talking about event history in system based on event sourcing. Who is working with event source system on a daily basis? Yeah, majority. Who is interested, like considers? 3 hands, four hands, yeah. So, and I guess that's the reason we are here, because if you didn't work with event source system or had no interest in that, you probably wouldn't come here. And so in that case, I don't need to spend very much time on explaining reason to choose event source system, because sort of devil's advocate question could be, okay, so since you came with this topic for your talk, it means that you know, there are some obstacles and some potential problems. So if you have a system that only persists current state snapshot, doesn't have advantage that you don't need to deal with history. So you have typical state-based system where you have a database where you store, this is a user record, this is a customer record, this is a company record, and just latest state is persisted. Then you don't have a problem of dealing with event history. But of course, since you are more either working with the systems or interested in that, you know that that's actually poor argument, like no old events, no survival change, because the reasons why people choose event sourcing, there are many reasons. And there was a great talk just before lunch by David Boyne about event-driven architecture. Who went to this talk? Yeah, I like it very much. And then, so he was talking about complexity of architecture, and he was actually telling us that you can't avoid complexity. So you can't design your system that to prevent it becoming complicated. Then, but you should be able to learn managing complexity. And to me, like state-based system where you just store the recent state, it's an attempt to avoid complexity. So we don't store events, we just store a recent state, and we hope that we will design the system. It's a bit like a waterfall-based design. Like this is how we design it. Instead, we hope that we will not be dealing very much with schema changes. Of course, we will. So I think that event sourcing leads to proper event versioning. So system evolves, contract evolves, and domain model evolves. So it's inevitable. So you'll be dealing with that. So it's better to be serious about that. You will have events that change over time, and then you just store them, you deal with that, and you encounter it at the early stage of your development. So if you build your state of your entities from events, then you know, a regular playback of all events, it will lead to early discovery of inconsistencies and breaking changes. Because if you don't build your state from event, then like you have snapshot, and then its system will be more vulnerable to like aha situation when something has changed and the system no longer works. But if you gradually change your system and rebuild regularly your state from your events, you will learn you will make systematic choices about your system development. Also, systems that are built with assumption of a single set of events are harder to adapt to software contract revisions. And I watched some talk where speaker told about some companies who had to backport new versions of some components because they couldn't version their events. So it wasn't compatible with like new version come with expect new events, and then the system was not capable of that, so they had to backport. So that's also consequences of not trying to deal with event versioning. So should a system based on event sourcing be able to handle events of any age? And if you Google, if you find talks about that, presentations, articles, then the popular opinion actually is contrary to what I'm going to talk about today. Keep your event streams short. So there are many arguments from recognized experts in the system that you should not strive to have a system with long event versioning. And there are some reasons for that. So first, of course, performance considerations. So if you have a very large number of events per entity aggregate root, and then replaying entity event is slow. Like, example, you have a bank account. And of course, you can't just replay bank account state from day one. You have to do some snapshotting. And then that's kind of an argument that you will get better performance. The answer to that is that in such systems, you will still need to deal with snapshotting because even if you keep event stream relatively short, it will still be not good enough if you have a very large number of events. So then you will still need to have a system that manages that. And then there is not really a big difference of having all full history or just short history. But then storage costs. Of course, operational storage versus archive storage. Working at a media publishing house, we experience quite significant growth of storage cost. We're dealing with video, it's very large files. And especially the last couple of years, we see that we really need to optimize our storage cost. Of course, if you're collecting like billions of events, that can be important argument. Then entities may have business life cycles. There is a pattern which is called closing the books. Example of this, you have workers which work in a shift. There is a new worker coming to the restaurant and then has his own register, cash register. And then, so he starts the shift and then he closes, the previous worker closes the book. So the new one starts from zero, so to say. If mostly your entities have business life cycles, then maybe there won't be significant advantage of keeping full history, and then you can actually have your event stream short. And last but not least is GDPR requirements. And this is quite important factor, and everyone needs to adopt to that. Oh, most of, at least everyone working with like end users, with people. It can also put requirements on your system not to deal with all the events because of GDPR requirements. However, let me present unpopular opinion. Keep your event streams as long as you can, which of course requires certain assumptions to be in place. So what are the reasons to keep stream as long as you can? Well, first of all, we don't intervene with a natural sequence of events. Because if your state is naturally built in the event source system from events, then all this thing about snapshotting, this is mainly for optimization. I mean, but naturally, it's built from events. This is an event audit. So unless you had reasons which I listed in the previous slides, then why should you start by keeping event stream short? Entity business lifecycle is perpetual. The books are never closed. And this is what we experience in our domain. So our media sets, like TV programs, radio programs, they have history of broadcasting rights, of files. We even had situations where we need to roll back to the previous version of the files if new files contain some errors or some incorrect content. Keeping the whole event history accessible makes all events available for continuous domain modeling. And then I think this is an argument which becomes particularly important in the year 2025, where every second talk is about using of AI. If you look at how vendors build electric cars, then you will if you look at internals of what they collect, often they collect a lot of data. They have a lot of sensors, sometimes without clear understanding of how they're going to use it. For example, how to build self-driving vehicle. It's a process which containing of multiple steps. So you build a version and then you find out that it incorrectly recognized traffic lights in some cases. Who was at Jennifer's talk about Wordle yesterday? Nobody. She's from Microsoft, and she said that she tried to solve the Wordle puzzle using AI, where the Wordle is a game where you try to guess a word, and then if you have a letter in the right place, it's displayed in the green. If it's a word it's in letter is in the word but not in the right place, it's in yellow. Otherwise, it's gray. So she found that even though AI is usually good in recognizing colors, but if the task is complex, which consists of many requirements, where color is just one of them, often it doesn't correctly identify color. And this is something which may happen with self-driving car. And of course, if car doesn't correctly identify traffic light, that's a disaster. And this is why sensor data becomes very important for future releases. So if you work in a domain where you may find useful in the future using some of your data, then it will be very sad if you just cut your event stream short, remove all events, replace with some snapshots, because you won't be able to use them in the future. And that's quite important argument. And for us, actually, it worked several times that we suddenly found some of old data that we could use. So, and of course, that leads us to this hybrid approach, event sourcing with snapshotting, something which we are doing partly. So use snapshots for performance optimization. And also, it has built-in support in some actor model frameworks. But sometimes you must use snapshotting if you have a history of like thousands or maybe millions of events per aggregate route. But bear in mind that snapshots introduce additional versioning complexity. You should version events and you should also version snapshots. So, and event payloads, they should be small, but state snapshot might be huge. And we will talk later about importance of keeping event payloads small. So unless you really need snapshots, like you can introduce them always at a later stage. So let me go through my opinionated long event history survival guide, which is built on our experience dealing with old events. And when I say old events, I think in our system, the oldest events were registered around 2011, where we released one of the earlier versions of our media player. So it's like 14 years old, which is like old enough because we changed technical tools and programming languages, databases, message queues several times after that. So we will go through every step which is listed here. But in brief, so it's about first have a clear separation between commands, persistent and transit events. Of course, have a clear separation about domain and DTO types. And also define events for specific scenarios. So some of earlier mistakes we made, we try to make general purpose events. Developers are usually bad in generalizing things too early. And events is something that probably you don't need to generalize even at a later stage. Even if you see that there are several candidates of like general event. Avoiding large objects in event payload, and we'll look at why. Using version tolerant schema-based serialization, avoiding polymorphic event serialization, and a few words about event migration, because once in a while you need to migrate your events. So what are recommended approaches to that? So first, it's have a clear separation between commands, persistent and transit events. So commands. Commands, it's something that usually specified in your contracts. It can be a verbal contract between different teams, but usually it's good to document your commands in contract using like Open API or Sync API specification. And you need to be certain about like ownership, who owns contract, who is entitled to change commands. They're expressed in imperative mood if this is how you call your commands in your programming language, and they may be accepted or rejected. So when you get certain commands, it's not obligation for you to accept it. But once accepted, they trigger event that is persistent, and that is a rule. That is something that is serialized. And in our case, we're using akka. So we use so-called persistent actors, and then they use persistent event journal. So we have a lot of support from akka framework for that. Commands, of course, can be persistent in audit log. This is what we do as well. So persistent journal events. This is something that's owned by the team. So we can change those events at any time. So this is something which we version. They're expressed in past tense. They may not be rejected. So they notify about the past. So typically published media file and then arguments with media file qualities. And they provide foundation for event sourcing. So we own those commands, and this is what we'll be talking about versioning. And then we have transit events. It's typically notifications. So they can be published internally or to external consumers. So we also call it outgoing events. And they may use so-called outbox pattern. So we can temporarily persist them because it's a part of the contract. Once the command is executed, we need to notify our subscribers. And then if we didn't notify, like let's say the system crashed, then when the system restarts, we must find out that we need to notify the consumer. So, and because of that, we use so-called outbox pattern, which basically means persisting outgoing events. But once published, they don't need to be replayed in its original shape. So they're not part of this core event versioning. So as like simplified view of what we are dealing with is commands, and once command is accepted, it's persistent in event journal, and we have outgoing events. And desired state events and current state events, it's not something that you have to use in your system, but this was our choice. That for us, we have chosen that the easiest way to deal with command execution is that we receive commands usually from the message queue, like RabbitMQ or Azure Service Bus. Then we register desired state, like what we are asked to do. And then desired state of the system is built from desired state events. So this is what we're supposed to do. And then we acknowledge the command, acknowledge RabbitMQ message or Azure Service Bus message, and then we start executing this command based on desired state events. And then once all current state events are received, so basically it's a mass. We have desired state, we have current state, and then difference is the workload which we need to do. So once we're done, we can send outgoing events. So this example of what's going on in our system. So we have a command publish media set, and this command consists of multiple files, multiple media files, which can be video file, audio file, subtitles. So we store journal events, like assign desired state, which describes what needs to be done. Then we start uploading files, like assigned remote files. So we received the first file as, sorry, it is just assigned. We need to upload 2 files, and then we received from our so-called origin, which is a remote storage. It's Amazon S3 compatible storage. We receive remote file state. OK, we publish outgoing event. We receive remote file state 2, publish second event, and also the whole media set is published. So these are journal events, and this is something which we try to version periodically. So in addition to separating commands, journal events or persistent events and transient events, it's also important to separate domain and DTO types. And unfortunately, in 2025, we maybe not very often, not as often as before, but we can come across systems built like that. You have just core types, which are domain types based on entity framework, for example, and both UI and business logic and even database use these types. And then what can I say about that? Actually, just don't. I mean, don't do that, because you're asking for troubles. You have to have clear separation between domain and DTO types, because they are actually, they exist for different reasons. Domain types, they represent current understanding of the business domain. And your DTO types, they're tailored for specific versions of specific contracts. Your domain types, they reflect the relationship between business entities, but DTO types don't need to bear this information about relationships between different entities. They must be lightweight and independent from each other. And also domain types, they usually use full expressiveness of programming language that you choose. And our programming language is F#. And F# is one of the languages that supports so-called algebraic data types, which means that we have sum types and product types, and discriminated unions and record types. So, and we take, of course, full advantage of that. And we can't design our DTO object based on like beauty of our programming languages. They must be based on primitive, well, they should be based on primitive data types. Otherwise, again, you're asking for troubles. So it's quite important. Once you have clear separation between domain types and DTO types, you make your life easier also when it comes to event versioning. Who is using AutoMapper? Good. Well, unfortunately, Jimmy Bogart, who wrote AutoMapper, is here, and he's a great developer, and actually he's very skilled into building great architectures, and he wrote this document about automapper assumptions after numerous complaints that somebody used automapper and then code is bad, and then why we're using automapper just to connect database to UI, and that's not how it should be done. Why did you publish this library, basically? So, and then he wrote this document, automapper assumptions. So if and only if your use of automapper falls into this list of assumptions, then it's okay to use it. But unfortunately, I checked today, automapper has 750 million downloads, so 750 million. So unfortunately, a lot of teams use it just to bind everything together, and that's really hard for maintaining the system. So define events for specific scenarios and avoid general purpose events. And that's one of the mistakes which we did in the early stage. That's actually from our code base from different times. We publish files, upload to so-called origins. It's like storage provider, and it used to be Akamai. Now it's S3 compatible storage, and then we had a received remote file state, which was a generic event, which contained some common information, and then origin type. And then what we found that it's in event-sourced system, it's much easier to manage events when they are specific to the context. For example, like what could be difficult with that definition? We actually phased out like Akamai storage. So, and we had millions of old events which just lies in the database without any purpose. And I'll be talking later about event migration, but even though event journal is usually immutable, but sometimes you have some events that just that will never be used for anything practical, and then they're just collecting dust. So you can remove anything that has to do with Akamai. And in case event was registered like that, you can't just, if you like event is stored in a SQL database, you can't just find them easier, but just by querying, because it's not stored as a column, like origin column, file set column, and so on. It's just a payload, it's just a blob. So actually you have to go through event journal and manually pick up these events. So another reason is that, of course, the more you work with specific origin, the more you find things that are related to the specific origin which may not be used when you introduce a new origin. So that's another reason why you shouldn't have this general use event. So events should be bound to specific scenario, to specific context. Then it will be easier to version them, it will be easier to get rid of them and enrich them. And downsides of generic purpose events, as I already mentioned, that versioning must be applied to all scenarios. And it's harder to perform cleanup in case some scenario becomes obsolete. I also originally had this, like harder to query for events for specific subset, but in a well-designed system, you should be using CQRS, like query and command separation. So then you shouldn't really be doing query on your events. You should be doing query on a read side. So probably it shouldn't be applied in that case. So another point that can become important, avoiding large objects in event payload. So there is a temptation that you can make events that contain everything. And then I had example with electric vehicles, and then if you want to build self-driving car, you have a temptation, of course, to register data from all your sensors, and then can make your events quite large. And of course, the motivation to have events large is that the content of events should be sufficient to fully rebuild the state of the system. And also the context of the events may contain information that can be used in the future. So just register everything. Maybe we will use for that. But there are some important downsides of large event objects. First of all, they have very significant impact on performance and scalability. If you have event-sourced system and then building state from large events, it really can bring your system down. Then there is a transport and storage size limitations. Again, if you're talking about events that will live long, then most likely you will change transport, you will change databases, and you can experience that something which was okay today will not be okay in the future. So here's an example of our event. On the left-hand side, this is how we implemented it, and so you have this information about completed file transcoding, which is version, bitrate, duration, and so on. And of course, you have string file paths, because it was obvious when we designed this event that we can't just put byte payload, because video file content can be up to 10 gigabytes. So in that case, we made right decision right from the beginning, because it was too obvious that we shouldn't put the whole file here. But we did mistake with subtitles, because subtitles are usually small. So instead of having just file paths, and in that case we would be treating subtitles in the same way like video files, we put the whole file content, because we're talking about maximum maybe 1 megabyte for subtitle. So subtitles file contain up to 1 megabyte. And then actually there are some consequences of that choice which we experienced, because we were using at that time mostly RabbitMQ, and then it was message size 2 gigabyte. Actually, up to version 3.7, and on later versions they reduced the size to 512. But anyway, it was no problem to use that. But in case some of the RabbitMQs were later migrated to other storage queues, like Azure storage queues and Azure Service Bus. And if you work with Azure storage queues, then it's just 64K. So of course, subtitle file will no longer fit. With Service Bus, you have up to 1 megabyte for premium subscription, but still it's kind of on the edge. You have to you have to at least be aware if you want to have a quite large payload of events. Why do you really need that? Because you can migrate your transport, and then suddenly you start having these problems. So what if event payload grows large? What are the consequences? So TCP packet size is 64K. So large messages require paging them into buffers. And so you will have like blocked buffers, block sockets. So real large events, as I showed on the previous slide, fit into queues and storage fields. And also you have to ask, maybe your events include the whole state, because this is, it can be anti-pattern, not necessarily in case you really know like what you're doing, that you need the whole state. But if you're dealing with event source system, then you build state from events. You don't just send state in your events. Maybe you can split your events into several smaller events. Again, it's not always possible. Maybe you need to have atomic events. But if you can split, that's a possibility. So with payload size, there is no strict rule telling you that you can't have events with large payload, but there are many obstacles if you have a large payload in your events. So just be aware of consequences when you design your events. Then another topic is use version tolerant serialization and to avoid so-called polymorphic event serialization. So what is polymorphic serialization? So typically you deal with that if you in languages like C# or Java, when you have types and subtypes, when you have serialized or deserialized your objects with preserving runtime information. And it's essential when dealing with inheritance. So you have like user, and then you have like company user, corporate user, private user. They derive from the same type, and then you use polymorphic serialization to, and then you need to store some runtime information. This is a corporate user. This is a private user, and this quickly becomes too much platform specific or language specific. So if you then change your platform or language, it will be hard to deal with this. So yeah, the key component of polymorphic serialization is you have base class and derived classes. And serialization formats can be anything like JSON, XML, binary, and your type information must also be present when serializing and deserializing your types. So problems are serialize and runtime upgrades. So sometimes if there is a .NET core or like .NET upgrade, it can come with problems with serialization. Actually, it happened in the past. Namespace changes. That's actually one of the things that we suffered from. Because we had to, with polymorphic serialization, usually it has runtime information that includes namespace. So if we just move class into different namespace, then suddenly it no longer works. But basically there is no place for class hierarchies in DTO types. So DTO types must be primitive types. So just avoid making DTO types part of class hierarchies. So instead, I suggest that we use schema-based serialization. So in that case, structure of the data, its schema is explicitly defined and used to guide serialization interpretation process. So no this runtime information. And there are several choices. One of the most popular, of course, is Google protocol buffers, protobuf. There is also Apache Avra, which uses JSON, Apache Thrift, and of course you can use XML with XSD. So this is an example of Avra schema. So you define your serialization format, your type. It's pretty self-explanatory. And this example of protobuf schema, something which we are using. So you see no class hierarchies, no complex types. Everything uses just primitive types. We choose Google protobuf because of its performance and compactness. It has very small message payload size, and it's very fast, extremely fast when it's serializing and deserializing data. Also, it's based on static typing. It's a bit opinionated, but we go for that. And of course, it's cross-platform compatibility. So it's supported by all major programming languages platforms. So if you choose protobuf, then you don't need to think about changing of platform. Who is using protobuf? What other serializers are using? Anyone using Avra? Apache Thrift? Just polymorphic serialization? Anything else? Sorry? Utensef? You happy with the choice? No. You have to. We still have Utensef JSON as part of our system, but in everything which has to do with persistent events, we replace with protobuf. After certain problems with both versioning and namespaces, actually. But yes, it's still, we're slowly replacing Newtonsoft with system text JSON, which is much faster, by the way. So this is also a little bit opinionated, but Protobuf doesn't care about naming, which I find personally quite good, because developers are religious about naming, and then can be religious about naming. And then if you're talking about a system that lives for years, like system outgrows its members, and then you have a team with strong opinions about how things should be named, then main, like lead architect goes, and then there is another guy, he thinks, no more Pascal convention, everything should be using like this good old C, and then suddenly you have different names, and probably you experience some naming wars between developers. And then if you have projects that are supposed to live decades, it should be also name agnostic, which Protobuf does. So all those names, actually, they have no meaning inside the Protobuf protocol. It's just for your convenience, basically. So these are indexes which order of the field, which is important. So you used to have a record ID, which was string, and now you replace it with user ID in later versions. So what you do, you mark it as reserved, because what is immutable is field order ID. So that will never be used, but instead you introduce user ID. It must have number 8, because up to from 1 to 7 already occupied. And then you change creation time to timestamp, you change last name to surname, and so on, and birth date to date of birth. And then you can do that. And then actually we did that, even though it's the same, mostly the same team, but we have over years different meaning about how things should be named. So, about event migration. So when we're talking about surviving long event history, we try, of course, to live with existing events. There can be situations when we want to migrate our events. And in that case, of course, we should prefer out-of-the-store migration. What means out of the store? It's that like migration in place, in memory. Sort of, you read the event, and then, but your current understanding of its place in the states is different. So you add some transformation of its fields, and this happens in memory. So event is immutable. So the preference should be for event being immutable. But it's good to at least to plan support for in-store event migration if you will need that. So what can be reasons to migrate event history in store? One of the reasons is performance. You have like billions of events, and some of the events no longer valid. If you're dealing with financial system, probably that won't be the case, because everything which you ever registered will still need to be in place. But in our domain, as I was talking about replacing the origin, like file storage provider, and then we're done with the previous file storage provider, so anything that we registered about files placed there is no longer valid. There is no such storage. So, and we have millions of events like that. So we could just remove them. So that's one example. Yeah, storage cleanup. Data error correction. Of course, there can be some data that were incorrectly registered, and we want to correct them. Probably, if you know how to correct them, they can be done out of storage, like in memory. In some situations, it may require out of storage migration. And then broken backward compatibility, which is actually a bad sign. Usually it shouldn't happen, but let's say you need to backport changes due to new requirement. And elimination of code complexity or technical debt. Well, it's good first to consider event deprecation, deletion, instead of migration. So again, if you need to migrate event, it's probably you haven't designed event correctly in the first place. So if it's some old event, then you should just deprecate it and skip when you read your state, your event to build a state. And there is a very important event migration rule. So a new version of an event must be convertible from the old version of the event. If not, it is not a new version of the event, but rather a new event. And that's probably the sort of cleanest way of migrating your event journal. If you not happy with the content of event journal, just create some new events. So you can deprecate old events, you just skip them on reading, just create new event that will proper represent your what happened to your system. So with that, I went through this opinionated long event history survival guide. This is again something that we practice with our domain. In case you're dealing with very large number of events, who is dealing with billions of events? Nobody. With millions of events. Yeah, so we are dealing with millions of events. So I guess if some of you worked with like online trading, then some of the advices, for example, event migration, it's harder to deal with that because typically in such systems they just don't have a chance to migrate anything. They just have to live with that. But for event journals like with millions of events, we found that by using these recommendations, we can actually maintain our system and keep events in place. And after like more than 10 years of using a system, still all events are played back and they build state of our entities, of our aggregate roots, or as they say in DDD. So we still have some minutes, and do you have any questions or maybe something you want to share or disagree with? Yeah, please.
How do you take the snapshot? Do you take the snapshot in the event stream wherever you are holding it, or a separate place or separate data window? I don't know what you use to store the website. How do you do a snapshot?
There are different strategies, and we're using, as I said, we're using Akka with it's actor model framework, and some of actor model framework they actually have built-in support for that, which was not sufficient or sort of good enough for us because we want to have full control of dealing with snapshots. So what happens is that when first of all we don't take snapshots for entities that we know won't grow in its event history by more than a few hundred records, because it's cheaper, it's faster actually to read hundreds of events, build a state, than to do snapshotting and play back events on the top of it. But we have some entities which had thousands of events in history, in particular those which we used in system testing. What we use in system testing, we have some examples, some test TV programs, which we every night we go through full process of uploading them to storage, deleting them. So it's like a few hundred events a night. So after several years, it's the same TV program, same ID. So they have like 100,000 of events. And then if you try to build a state from event journal, like every time you read it, no, it many seconds. It takes many seconds. Can be actually take more than a minute sometimes. And so we have a, a rule that we take snapshot every 100 rows. So and this is what happens is that if event is written, then if every event stored as event journal with persistent ID, which is ID of its entity, sequence number, and blob, payload. So it's very simple structure. And event name, of course. So if sequence number divided by 0 division by 100 is 0, yeah, just take snapshot. And then with it's asynchronous operation. We just send the command, okay, take snapshot. So the actually execution, business execution goes its way. But at the same time, snapshot is taken. So when next time we want to read that entity, and this is actually implemented by akka, it sends event, internal event like snapshot offer. Okay, you want to read your state, but there is a snapshot offer because current sequence number is 3120, but there is snapshot with 3100. Okay, you take this snapshot and then you play back all events after that. And this is actually managed by this offering snapshots and playback after that, managed by akka, but it's very easy to implement. If you don't use actor model, you can just implement yourself. So this is standard procedure. Does it answer the question? Mm-hmm. Mm-hmm.
When you delete, let's say you have thousands of events, and you want to delete some of them from because they are 10 years old.
Mm-hmm.
Do you go and delete, or do you set the TTL that they let it remove itself? Because obviously it's another operation of database which might affect performance.
Yeah.
How you do that?
Yeah. First of all, I must say that this was the last point, that support instrument migration. I presented this talk in another conference, and then it got some attention from people say, okay, so should we be doing it regularly? And then so I'm afraid maybe I put too much attention to that, because in general, unless you need to deal with all the events or migration, basically the immutable event journal is where you want to start with. But like in our example, we have millions of events registered for old origin, which will no longer be used, and that doesn't have any sort of commercial obligations. So it just since we're using event journal, which is stored in a SQL base, and then it has a unique primary key, which is persistent ID and sequence number. So, and also there is a event name. So it's this can be done just aside. You just run basically SQL script by going through the event journal and deleting those events. Or another thing which we implemented is that the actor itself, basically actor is a little daemon that lives in associated entity. Actor is TV program, actor is a radio program, is actor model, it works like that. So when the actor starts, which means that particular TV program is being executed, we want to do something with that, it can analyze it, say, okay, by the way, I have some old events. And then, okay, let me clean it up. So depending on how you want to implement it, just by doing it at once, running a script, you can do that. But we have self-maintaining actors, because we're using actor models. So typically, when actor awakes, it cleans up. It looks at, okay, do I have something I need to do better? Okay, I have some old events. Let me sort of clean it up. I have something that's some pending work. Let me do upload some files, something like that. So it's both will work. Any more questions? Okay.
What's the difference between materialized view snapshot?
Materials view. It's something like in Oracle, for example, you have material view. That's
Serialized view of an account where we replay all the messages up to the latest version and say that's the aggregator of the account that we present. What is the difference between that and the snapshot? Is it just the same thing?
I think that for logically, probably like usage of it will be the same purpose. It's just that materials view something that is offered by your database typically. Snapshot is when we have sort of minimal focus on the database, and if you look at our event journal, it has two tables. One is like event journal table, which is very simple, consists of persistence ID, sequence number, payload, and like event name, and another table, snapshot. So and we decide that okay, every once in a while we take this snapshot. So if you if your database offers you materialized view, which will be automatically managed, so you will get like latest data, then you can do that. But we try to not to delegate to database like business tasks and like building snapshot, because snapshot is your state. So it's kind of business logic. So you apply your business logic to your events, and you build your state. So we won't have sort of to have full control of it, and then don't let sort of database to be responsible for building state from events. So I think it's more like implementation choice, where what you prefer. So if it gives you exactly what you want, like the state of your entity, then it should be good enough. But we just periodically take snapshots, and this is also transition in actor-based model, because you have an actor which built from events, and then for optimization reasons you take snapshots, which goes in different table. Okay, if there are no more questions, then thank you very much for coming to my talk, and there are a couple of other talks still on Friday, so enjoy the rest of the conference. Thank you very much.